Okay, so question 1 says, from the circuit below, calculate one total resistance, that is I, then II, total current, III, current in each resistance, IV, voltage across each resistance, V, power across each resistance, and then VI, total power. So our circuit is this. Okay, this is our circuit diagram, and we have to calculate for the total resistance, total current in each resistance, voltage across each resistance, power across each resistance, and then total power. Okay, so before we move on with the solution, please make sure you subscribe to my channel. Okay, all right. So let's start with solution A. Okay, so from the circuit we have two resistors which are connected in series. Okay, so to calculate for the total resistance, what we do is we add R1 and R2. Since they are connected in series, we just add R1 and R2. So RT, which is the total resistance, is equal to R1 plus R2. That is 5 plus 10, which give us what? 15. Okay, all right. So let's move on to the second solution, which is the total current. Okay, so since it's a series network, the total current here is the same current that flows through the circuit. Okay, all right. So to calculate for the total current by Ohm's law, we say IT equals VT over RT. All right, so we have our VT here, which is 20, and then we just calculated for our RT, which is the total resistance. Okay, so IT equals VT over RT. So we have 20, which is the voltage, and then 15, which is the resistance. So when you divide 20 by 15, you get 1.33 amps. So our IT, or the total current, is 1.33 amps. Okay, so let's move on to the next solution. The next solution says, that is solution C, says we should calculate for the current in each resistance. Okay, so as I explained earlier, the total current, since it's a series network, is the same current that flows through resistor R1 and the same current that flows through resistor R2. Okay, all right, that means the current at I1 will be the same current at I2. Okay, because what is a series network? It's a series network. So when you come to the solution here, IT is equal to I1 is equal to I2, meaning the IT is the same current that flows through the two resistors. Okay, so I1 is the same as I2. Okay, so our solution is IT equals I1 is equal to I2, which is what? 1.33 amps. Okay, all right, so let's move on to the next one. So the next one says we should calculate for the voltage across each resistor. All right, voltage across each resistor. By Ohm's law, voltage is equal to what? IR, that is current times resistance. Okay, so when you come to the circuit, to get V1, we have to multiply I1 by R1. Okay, so when we multiply I1 by R1, we have to get V1. So that is what we have here. So V1 equals I1 times R1. And now our I1 is what? 1.33 times R1 is what? 5. Okay, so 1.33 times 5 will give us what? 6.65 volts. Okay, The same way, if we want to calculate for our V2, which is this, we have to multiply I2 by R2. Okay, all right. So when you come to the solution, V2 equals I2 times R2. Okay, that is 1.33 times I2, which is 10, which gave us what, 13.3 volts. I hope you are following. Okay, so let's move on to the next solution, which is solution E. E says we should calculate for power across each resistance. Okay, so for power we have three formulas. Power equals V times I, that is the voltage times current, or V square over R. Okay, that is voltage square over resistance, or current square times resistance. Okay, so we have three formulas that we are using, or you can use to calculate power. That is P equals VI, or V square over R, or I square R. They are all formulas that you can use to calculate for power. But in this video, I am going to choose the first one, which is what? IV. Okay, so since I'm calculating for P1, that is the power for resistor R1, I'll say P1 equals V1 I1. Okay, all right. So the V1 that we calculated, we got 6.65 times our current, which is 1.33. So when you multiply 6.65 by 1.33, you are going to get what? 8.84 watts. Our P2 is also equals what? V2 I1. I used I1 here because our I1 is the same as our I2, and is the same as our total current, because the circuit is a series circuit. Okay, all right. So our V2 is 13.3, and then our current is 1.33. So when you multiply 13.3 by 1.33, you get what? 17.68 watts. Okay, so let's do the last one. Which is the F. F says we should calculate for total power. Okay, how do we get total power? Total power can be calculated by multiplying the total voltage by the total current, or by adding the power for R1 or the power for R2. Okay, that is P1 plus P2 should also give you total power. Okay, so either P equals IV, or we can use this formula P1 plus P2, all should give you the same answer for the total power. Okay, all right. So from our calculation, our P1 was 8.84, and then our P2 was 17.689. okay, so when you add these two figures together, you're going to get 26.529 watts. So thank you so much, and once again, make sure you subscribe to my channel. Okay, thank you.